What's up, everyone? This is gonna be skill practice 36. Let's get right into it. Yes, sir. Okay, let's go. Number one, what underwater where temperature is 17 degrees Celsius and the pressure is 394 kilopascals, a diver inhales 2.1 liters of air from a scuba tank. Now, let me preface this video real quick. This whole skill practice 36, it's all gonna be Pivner. Everything. PV equals NRT. That's gonna be best friend here. Okay, so PV NRT. So the same thing as plug and chug. Yeah, let's go. So how many moles of gas are in his lungs? So is going to be N. That's the thing we're going to find. So let's plug in PV R and T. The pressure is going to be 394. Volume is 2.1. N is what we're trying to find. R is the something constant. That's always 8.134. Right, it's 8.314. That's just gonna be given. Um, yeah, 8.314. And then the temperature is gonna be uh 17 degrees Celsius. Aha. Were you guys paying attention? Because we do not use Celsius. We must convert Celsius to Kelvin. So 17 plus 273.15 is gonna be 290.15. And so we plug in chug 8.314 times 290.15, gonna be 2412. And then this is gonna be 394 times 2.175. We divide, it's gonna be, let me just rewrite this real quick. 785 equals. We divide both sides by this big number right here. And so N is going to be 0.32, 0.32, 0.33. My calculator says 0.33 moles. Okay. B, if the diver swims to the surface without exhaling, where the temperature is 32 degrees Celsius and the pressure changes to 100.2 kilopascals, what will the volume of in the air of the air in his lungs will be? So still plugging and chugging, the pressure is gonna be 100.2. Um, the volume is what we're trying to find. We found that the moles of gas does not the moles of gas is 0.33, as we found earlier. Right, this does not change. And then 8.314, that's gonna be the R constant. And then the temperature is not 32 degrees Celsius, right? Because we have to be using Kelvins. 32 plus 273.15. Give me 305. 5. So we just plug in chug 0.33 times 8.314. And so if you just plug in chug, you're gonna get 8.62 liters. Yeah, 5.15 divided by, yeah, 8.3 8.35 something. 8.62, 8.35. I'll get 8.355. Okay, cool. On planet X, 2.78 moles of gas takes up 1.85 liters under pressure of 74.1 kilopascals. And a temperature of 201 degrees Celsius. What is the value of the ideal gas constant R on planet X? So right, we're just trying to find what the constant R is. Plugging, chugging. Pressure is going to be 74.1. V, the volume is going to be 1.85. N is the moles is 2.78. R is what we're trying to find, and then the temperature is 201. Psych, it's not 201. It's actually going to be 474.15 because it's Kelvin. You plug and chug, it's going to be 0.103 liters over kilopascals. Right, the units for the R constant is going to be liters over kilopascals. I'm going a little bit fast through these skill practices, but if you guys like, because I'm like skipping the calculations, you guys need extra help, like me explaining why something happens, then ask me, and I will gladly respond. Unless I'm sleeping, I will not respond from sleeping. So how would I respond? All right, at a pressure of 103 kilopascals and a temperature of 22 degrees Celsius, 52.9 grams of a certain gas has a volume of 31.5 liters. What is the density of his gas? Hint, find the molar mass of the gas, match it with the periodic table. Okay, um, so we need to find what the N is, what the molar mass is. Molar mass is moles, so N is gonna be N is what we're trying to find. That's gonna be our variable. So pressure is gonna be 103. Volume is 31.5. N is what we're trying to find. R is 8.314. And then our T is not 22 degrees Celsius. It's going to be 295.15. And so we isolate N. It's going to be 1.322. So this is going to be moles, right? And so to find the molar mass, you put grams over moles. 2.9 grams over the moles. You're gonna get 40. That's gonna be grams per mole. And then you pull up a periodic table, and 40 is going to be argon. Oops. Pretend this is argon. Okay, yeah. Number 5. Some oxygen gas has a volume of 41 liters under pressure of 245 kilopascals and a temperature of 279 Kelvin. What is the mass of the gas? What is the mass of the gas? Okay, so plugging and chugging. P pressure is 245. V is 41. N are moles, is what we're trying to find. You don't know the mass. V is volume. Wait a minute. Oh, wait, hold on. RT is 8.314. And then T is temperature, 279. N is going to be 4.33. You just isolate N, right? Same thing as before. You have a 4.33 moles, and then oxygen, right? You need to find out what the mass is. You need to find grams. So the ending has to be grams. You have to set up a table. Moles on the bottom, grams on top. The molar mass of oxygen is 32 because oxygen is in its pure form. So it's 32 diatomic, and 4.33 times 32 is going to be 138.56 grams. Okay. Number 6, if 17.5 milliliters of oxygen were collected at room temperature, 22 degrees Celsius, and 100.2 kilopascals of atmospheric pressure, how many moles of gas were produced? Okay, moles of gas. N, we're trying to find N. P is going to be 100.2. V is 17 point, oh wait, hold on. 17.5. No, actually not. Volume, the terms for volume, the units for volume is actually liters, not milliliters. And so in order to convert 17.5 milliliters, you just move it 3 decimal places, 0.0175. Oops. One seven five. That's the thing working. Please work. 175. Oh, thank you. Oh my gosh. Okay, cool. N is what we're trying to find. R is gonna be our constant, and then T is 22 degrees Celsius. But remember, we need to convert it to Kelvin, so it's gonna be 279. No, it's gonna be 295. 295.15. N is going to be 7.14. 5 cents to the -4. B, what is the molar volume of the oxygen gas at the conditions in the laboratory? So molar volume, right? So molar mass is grams over moles. Molar volume is going to be liters over moles. So we have liters is 0.0175 divided by 7.14 times 10 to the -4. 0.0175 divided by 7.14 or 10 to the -4. And then you're gonna have 24.5 liters over moles. Okay, number 7, last one. What is the molar volume of a gas at 135 kilopascals and 45 degrees Celsius? So we don't know molar volume, right, is liters over moles, as we said earlier. So with using PV equals nRT, you can actually manipulate this thing to get liters over moles, right? So liters is V. So if we isolate V, it's gonna be V equals nRT over P. And then moles is N. So it's gonna be V over N equals RT over P. R is the constant, so it's 8.314 times temperature. Not 45 because it needs to be in Kelvin. So it's 318 over, and then the pressure is 135. And you're gonna get you're gonna get 19.6 liters over moles. All right, that is a skill practice 36. Happy studying. Goodbye.